Similarity of triangles. It's about two triangles. Let's say this triangle and then another triangle with different measurements. And we want to prove these two triangles are similar. There are three cases. Simplest one is if you know these two triangles have two equal angles, two congruent angles is better to say. If you have the values equal, but if you know these are congruent like that, you know, with our value we say congruent. Two congruent angles. Then if you have this, then you can say those two triangles are similar. Cool? Like what? Two angles. So one of them is, let's say this angle, I already draw it. This angle is called that angle. Let's label them A, B, C, D, E, F. So this is the given part. If you have that given, they can conclude this. So the given is, if I know angle A is congruent to, oh, that similarity is not like that. Similarity, that's congruency. Similarity is just like this. So if angle A is congruent to angle D, that's given, right? That's one of them. And the second one is this one, angle B is congruent to angle E, like that. So angle B is congruent to angle E. Means if this, for example, this is like 20 degrees and this is, for example, 80 degrees. You see that they're both 80 degrees. They're both, B and E are 80 degrees. A and D are 20 degrees. They're both same, right? So we don't care about the numbers now. Then you can say, then you can conclude what? These two triangles are similar. A, B, C is triangle ABC is similar to triangle DEF, right? So what is the point? This is just the first one. There's two others that we're going to talk about. This is angle, but what is the point of doing this? When you have this similarity, you can write this proportionality. That's what you can conclude from here now. From what you have, from this, you also can conclude something else. You can write proportionality. You can say, now, if we know these two triangles are congruent, I can write AB, that segment to the corresponding one. Which one is corresponding to that? So I cannot pick DF. I can't, like this one. I cannot pick EF. Because I picked AB is between these two angles, right? Then from the other triangle, I have to pick the segment which is between those two congruent angles, just DE. Cool? So AB over DE. Now, if I pick BC from the bigger triangle, and so numerator, I pick the big triangle, denominator, I pick the small one. You have to keep it same. If I, in the numerator, if I pick big ones, the big triangles, I have to put in the numerator over here, and over here, I have to put the segments of the big triangle. So over here, I'm going to say BC, and over here, I'm going to say AC. These are the segments of the big triangle. Underneath, which one is the corresponding to BC segment from small triangle? BC is this one. And then corresponding to that is this angle, right? And then third one. So between this angle and third one that we don't know. So it should be between this angle and the third one, which is this one. We don't know. So that's going to be EF. And then AC, which is this one, the last one left with DF. So when you know, so two things with it here with this example. One, if you know two angles are congruent, you can prove that because of angle, that's a theorem. Because of angle, this is called AA theorem. Two angles congruent with two angles from from one triangle with the other triangle, then you can say these two triangles are similar. Cool. And when you know they're similar, you can write this proportionality. All right, so that's just one thing that we did with angle. With another video, I'm going to tell you the other one, and the two other videos, I'm going to tell you two other similarities. So